Okay, in this problem we've got a elaborate two-shaft system here. Okay, they each have a diameter of an inch. They're both made of steel. Um, Basically, I want to find the angle of twist of A after all these torques are applied. Okay, so what I think I'll do is I'll start with this bottom guy here, and we'll kind of do my best to draw it. Bear with me. Okay, so it'll look something like this. And again, I'm looking for the twist of A. Okay, and what I have is I've got 40 on this guy. Okay, and then what I've got is if that guy is going in that direction, okay, to balance it, I need a force over here on this um, uh, gear like so to balance it out. Okay, and that force is going to be, okay, first of all, I want to go do everything in pound inches rather than pound feet. That way everything will be in PSI at the end. Okay, so again, this force, okay, that has a radius of 4 inches on the end of that guy. Okay, the torque it has to equal is, again, 40 times 12, again, to get that into pound inches. So it's torque of pound inches. Okay, I want to figure out what that poundage is, so again, I'm going to divide that by the 4-inch radius that is that gear. That tells me the force over on that end is 120 pounds. Okay, now the other thing I want to do is eventually I need to find the torque through each member of each section of the shaft that I'm going on. Okay, so that means that the torque through this is 0, right? If I cut it through there, there's no torques on it. Okay, so there you have that. Okay, and at this point now I'm just going to be talking about magnitudes. We'll talk about directions when I start adding these all together. So just for my brain, it's easier to just deal with um, the magnitudes. And the magnitude here is going to be that 40, but again, I want to get it in pound inches, so it's going to actually be 480. So now I've got the torque in pound inches through each section going from A to that gear and then from that gear to the other gear. Okay? And I know the force on that gear is 120, and I'm going to need that because it's going to show up in that top piece that I have right here. Okay, and again on that top piece now I have a force pushing up on that side of 120. That's what I just figured out from before. And then I've got an 80-pound torque going in this direction, and maybe I should call that 960 rather than 80, because I want it in pound inches, and I'm just taking that 80 pound-feet times 12 inches to get 960 pound inches on that. Okay, so I've got that, and again I'm trying to find the torque through each piece. So what I know is this section then is just going to be that 120 times 6 inches, which will be the torque on that edge right there because of the 120 on that gear there that is 6 inches away. So that's going to be, again, 720 in that direction. So again, that's going to be going in this direction that way. 960 brings it back in the opposite direction, so it's going to be actually in the other direction now of 240, which is going to be that 720 minus 960. And again, I'm going to go through the directions very much as I move forward, but hopefully again you go from, again, A from that first one, there's no torque going there because that's a free bearing over there. So then it's just the 40 times 12 going through that second piece. Then based on the fact that I know I've got a power transmission between those gears, which means I have 6 inches times 120, so 720 in that first one. And then I pull back in the other direction 960 to get to 240. So now that I've got these, what I'm going to do is I'll slowly go piece by piece. And again, I'm going to start from D and go to that first applied, that would be 964. So I'm going to call this point right here E, just so I have it labeled. So when I go and I say, okay, what's the direction of this? Now, as I look down that shaft, okay, and again, I'm looking at DE here. as I look down that shaft, right, this guy is going to rotate in this direction, okay? So if I look down that shaft, from the gear back towards the wall, that's the direction DE is going to twist based on that 80 foot-pound force being applied on it, right? That 960 is dominating everything, making it go that way, okay? And it's going to be, again, I'll do the denominator just to make things look a little cleaner. So JG, which is pi over uh, 2 times the radius to the fourth. And again, this is going to be steel, which is 11 times 10 to the sixth psi for steel for the modulus of rigidity. Okay, and again, this guy has 240, and again, I'm just doing magnitudes here, just thinking about what the directions are. Okay, and then that's going to be 10 inches, that section right there. Okay, and from that, in radians, I get 0.00222. Okay, in that direction shown there, which, as I have it shown there, is counterclockwise. Now going from E to what I'll call this end right here F. Okay, so EF here, that's going to be in the opposite direction, right? Because again, now I've got that 720 twisting in this direction as I look down. Okay, so that's in that direction. DE is in the other direction, right? So as long as we get them in that right direction, we've got that like that. Okay. Okay, so from that, again, do the denominator first. That's going to be pi over 2 times 0.05 to the fourth times G, which is 11 times 10 to the sixth for steel. The force or the torque in pound inches here is going to be 720. Its distance is going to be 30 inches. So calculating that, I get an angle of twist of 0.02. Okay, so now I've got that one whole shaft. So I can find the angle of twist of that shaft. Okay, EF dominates since it's bigger. So all the way from D to F will be in that direction, and it's just going to be 0.02 minus 0.002, which will give me 0.0178, and again, that's radians. And again, as I look down that shaft, that's going to be a clockwise rotation. Okay. Now, I have to find the twist of what I'll call point G here. Okay, so we're going to call that that gear that is attached to G. Okay, now based on how gears work, if DE is clockwise, then G, that gear, G, has to be in the opposite direction, right? It's going to have to be counterclockwise. And it's going to be related to the gear ratio there, right? So I'm going to find that is, I take 6 inches times the rotation of the larger gear and divide that by 4, right? And that's that gear ratio, 6 to 4 gear ratio. Okay, so you get that rotation of F, you get the rotation of G, and you find that rotation of G to then be 0.0267. So again, that's going to rotate a little bit more because it's a smaller radius. So that is now, again, as I look from B down to A, as I look down the shaft that direction, I get G going in the counterclockwise direction of 0.0267 radians. Okay. Now I need to know G to H, and really H and A are the same. A is going to do, and again, what I'm calling H is this guy right here. Okay, and A is just along for the ride. Whatever H does, A goes with it because there's no torque between H and A. So now I just need to find that twist going through there. Okay, so now this is GH. Okay, now that is also if I think about how that's twisting, that's also going to be twisting. Again, as I look down from B to A, as I look down that shaft, that's also going to be a counterclockwise rotation as shown like this. Okay? That's going to, so G is already twisted some. It's going to twist even more based on the torque going through there, and that torque again is 480 pound-inches. Okay, the denominator, pi over 2, 0.05 to the 4th, 11 times 10 to the 6th. Okay, and then that torque again is 480, and that distance is 10 inches. And again, A is what we're looking for, but it's just going to fall along with whatever H does. Okay, so from that I get 0.00444 radians. Okay, that is the twist from G to H. Now G already is twisting 0.267, so I just have to add those two things together to find basically how much H twists, which is the same as A. Again, A is just along for the ride, which is what I'm looking for. So it's just going to be those two things added together. They're in the same direction, so I add them. 0.0311 radians. And again, switching that to degrees, I get 1.78 degrees. So again, got to find the torque in each one, okay? And then just very methodically go through figuring out what direction, how things are going to twist, and you just using that TL over JG. Again, another thing to keep in mind, put everything in pound and inches so all your units will come out. Remember that you get radians, so if you want to convert to degrees, you can go ahead and do that. But again, a lot of it is just, again, methodically going through and figuring out how the twisting, what direction things are going in.